So what are we doing tonight?
I'm gonna look on the website real quick.
Okay.
What's the date, do you know?
Today?
Yeah.
May 3rd.
Alright. I have the homework right here.
Okay. Did you post that in the chat?
Yeah.
Okay. You want me to pull it up? I presume that's why you posted it in there? Okay. And word problems? Okay.
Yeah.
Let me expand this a little bit, and then I'll take a picture of it. A round swimming pool has a diameter of 15 feet and it's 6 feet tall. So we're looking at a right cylinder, correct?
Yes.
What's the area, or what's the volume of a right cylinder?
So we need to find the radius.
Okay. What's the radius?
Which is 7.5.
Okay. What's the formula for volume of a cylinder?
Pi r squared. Oh, well, that's not volume, that's just area.
Okay. You're only halfway there. What's the rest of it?
Pi r squared times area.
Times the height.
Oh.
In other words, pi r squared is the area of the base.
Yeah.
So the only other measurement to multiply it by is the height. So that's the formula for the volume of a cylinder. So just plug everything in. What do we got? Pi times 7.5 squared times 6. Come up with a number on that and give your answer in terms of pi.
So the area is 1059.75.
No, doesn't sound right.
You sure?
Positive.
Pi r squared?
Yeah, but r is 7.5. It's not 15. So start by squaring 7.5.
Yeah, it's 56.25.
Multiply that by 6.
Okay.
What is that?
337.5.
That's your answer times pi. In other words, you don't want to round it off. You don't want to use a decimal for pi unless she said round it off to 2 decimal places or something. But almost always when pi is part of an answer, you leave it as pi. You don't convert it. You're rounding it off. This is an exact answer. 337.5 times pi.
Yeah.
Okay. About the second one. So here we have a cube.
Yeah.
She wants to paint it. It's got an edge length of 4. It's a terrible question, the way they worded the question, but we know what they mean. Well, I think we do. Do you know what they mean on this? How are we going to solve this? Are we going to find the volume of the cube?
I guess so.
Well, what good's that going to do us? We're not going to paint the inside of it.
Yeah.
We want the surface area.
Oh, yeah.
In other words, if you're going to paint the cube, I'm going to paint that side, and then that side, and then that side, and then the other three sides.
Yeah.
So I got to figure out the surface area of all six sides.
Okay.
So what is that? First of all, how many sides are there on a cube?
6.
Okay, so it's 6 times the area of each side.
Well, 4 to cube. So it's 4.
No,
16 times 6.
16 is the answer of the area of each side. So 96 is the total square footage that we want, or square inches, excuse me. Everything's in inches here. So it's 96 square inches. See why that's kind of a bad question? Because first of all, you don't measure paint in square inches. If I went down to the hardware store and said, give me 96 square inches of paint, they're going to laugh at me. You buy paint by volume. So I need to know how much paint would cover 96 square inches to really answer their question, and they don't give us any of that information. So they really aren't asking how much paint will she need. It's how much area will she need to paint? That's the question. How much area will she need to paint? And the answer is 96 square inches.
Yeah.
All right. Number 3. He's building a fence at the side of his warehouse. All right, here's his warehouse. And he's building a fence like that, using the warehouse as the 4th side of the fence.
Yeah.
Okay. He's got 120 meters of fencing.
Yeah.
Now, before we can solve this problem, we need to put some variables on here. Because we need to figure out, the question is, what are the dimensions of the fence so that they would have a maximum area? So we need to solve for the dimensions of this fence. So give me some variables to put somewhere. What's the bottom side of the fence called? X. What's the vertical measurement called? We'll call it Y. What's the top side?
Called Z.
No, that's still X. This is a rectangular fence.
Oh, yes.
Okay? So there's our fence, and there's our 2 variables that we need to solve for.
Yeah.
Now, we want the largest area. So the function that we're going to try to maximize is the area that fence encloses. What's the formula in terms of our variables for the area of that fence?
X times Y.
Okay. Now, there's another equation that they're giving us information on. He has 120 meters of fencing total. So what's another equation? What's 120 meters equal to?
Oh, it's something squared.
Well, not yet, but we'll get to that. What's 120 equal to in terms of my diagram?
Your total amount of fencing.
Isn't it X plus Y plus X?
Yeah.
Which is 2X plus Y. Okay?
Yeah.
Now it's key to realize that we have two variables and we have two different equations. So we're going to be able to solve this, because all we got to do is substitute. Okay? Don't need the units on there. Solve the equation on the right for y. What do you get?
You will get y equals, hold on, write this down real quick.
Okay.
Y would equal 120 plus 2x.
120 minus 2x.
Oh yeah.
Remember, I got to get that 2x to the other side, which means I got to change the sign. Okay. Now, let's go over to our main equation, and I call it the main equation because that's the one we're trying to maximize.
Yeah.
Okay. Well, in terms of one variable only, I'm going to substitute 120 minus 2x for y. So that's going to give me x times 120 minus 2x. You with me?
Yeah.
Okay. Now, I'm going to solve that. That is a quadratic. My area is minus 2x squared plus 120x. You see how I got that?
Yeah.
Okay. Now, we're trying to maximize this function.
Yeah.
What kind of function is this? What's it look like? What's it called?
I should know this.
Yep. What shape does it make?
Square.
No. It's a parabola.
Ah, yeah.
Okay. And there's one thing very important about a parabola. If it points down, then there's a maximum right there.
Yeah.
If it points up, then it has a minimum. Well, we can see this is going to point down because it's got a negative sign in front of the x squared term. So we know we're dealing with one that points down. So as all we have to do is find that vertex. And we will solve this problem. Because that'll give us the x coordinate. In other words, we're looking, you can put that into a graphing calculator also. But we don't need to. What we're looking for is that spot where the function is at its maximum value. Well, how do I find this spot? How do I find the vertex of a quadratic?
Vertex of a quadratic.
The x-coordinate of that vertex is minus b over 2a. That's a good one to remember.
Yeah.
You don't always figure out the vertex by using it, but in this particular case, it's the easiest thing to do. I'm not trying to solve this quadratic. I'm just trying to find out where the x-coordinate of the vertex is, because that's going to tell me my dimensions on my fence. Once I have the x-coordinate, then the y-coordinate will be automatic. We'll know what it is. So what's minus b over 2a?
Minus b over 2a.
What's minus b?
Are we plugging in x and y for this?
Sorry, what?
Are we plugging in x and y for these?
No? Here's what we're doing. We have a quadratic function here.
Yes.
My x-coordinate of the vertex of that quadratic is minus b over 2a, where b is the coefficient of the x term, and a is the coefficient of the x squared term. So minus b is minus 120, and 2a is minus 4, so I've solved it. I have an x of 30. That side has to be 30. That means that dimension is 30. And since 120 is the whole thing, that side has to be 60.
Yeah.
So the moment you solve for x, you're basically done. The rest of it solves itself in terms of the total dimensions of the fence.
Yeah.
And that's 120 feet of, or 120 meters of fencing. And that does maximize the space. That's the maximum area, which is 1,800 square meters, that you could get out of a rectangular fence.
Yeah.
All right. Let me scroll down and take a picture of this. A lot of these, sometimes you just want to draw a picture to be comfortable that you're looking at it in the correct way.
Yeah.
So let's do that. So here's the corner of the garage, right?
Yeah.
And he's got a dog on a leash. The garage is 20 by 30. We'll make that side 20. We'll make this side 30.
Alright.
The leash is 24 feet long.
Yeah.
How much area can the dog access? Well, you can go to there. You can go to there. Hold on a second. Ooh, this is a lot harder than it looks. I don't think he intends it to be that hard, though.
No, we did one of these in class today.
Yeah, no, it's not as easy as you think. It's not going to be as easy as you think either.
Yeah, I know.
Not the real answer, and I'll explain in a second. This is the picture they want you to have, okay? So what are we looking at? We're looking at 3/4 of a circle, are we not?
Well, yeah, but we also got the other quarter, which is a different quarter of a different radius.
Well, let's first of all figure out this area. This area that I've drawn is 3/4 of a circle.
Yeah.
3/4 times pi r squared. Pi times 24 squared. So that's this area that we're talking about here. That's pretty straightforward. You can get that number out of your calculator.
Okay. 3/4 times.
But here's where I think he screwed up. I don't think he intended it to be this way. And that is the 24-foot long leash goes beyond the corner of the garage.
Yeah.
So maybe he did mean it to be like that. But
Oh, no, they did. Trust me, they did, because we talked about it.
okay, good. So here's really the picture. There's the garage. And the leash actually lets him go some distance there. And I guess that's 4, since it's a 24-foot leash.
Oh, yeah.
So he actually has that other little quarter of a circle,
Yeah.
which is 1/4 times pi r squared, where r is 4, I think. Let me think about this for a second. Yeah, when he gets to that point, he's got 4 feet left on his leash. So it's 1/4 pi times 4 squared. So that's our answer, whatever those two are. He did intend it to be like this?
Yeah.
Okay. Where it's not just the 3/4 of the first circle but also 1/4 of the second circle. That's the way he explained it?
Yeah.
Okay, good. So he did one in class like this?
Yes.
Okay, cool. Yeah, because when the dog gets to this point right there, he's got the leash fully extended, but he can still go to there. So he has another small quarter of a circle he can go to.
Alright, so for the first one I got 432.
Yeah, I'm not checking your answers on the calculator here. You can do the calculator part easily enough. Right? I mean, you can use a calculator for these?
Yeah.
Alright, I would just square 24, multiply it by 3/4, leave it in terms of pi, and the bottom little circle is going to be 4 pi. In other words, this is going to be 4 pi, and this is going to be some number of pi. I don't know what 24 squared is, times 3/4. What do you get?
4.
No, square 24, multiply it by 3/4. What do you get?
432.
So we got 432 pi plus 4 pi. We got 436 pi as the answer. That's how much area the dog can access.
Yeah.
Okay. Now let's look at the next one. What's the answer going to be to solving this? What do I have to do?
Hold up.
Is it an area problem? Is it a volume problem? Is it a linear problem? What is it?
Area. No, volume.
It's volume. You're talking about how much popcorn can you put inside of a box? That's a volume problem. So what's the volume of the box on the left?
We gotta find that out.
Well, what is it? What's the general equation for volume of a box?
Base times width times height.
Okay, what are they here?
10, 10, and 20.5.
Not pi. 10, 10, and 20.5. Is that what you said? You might have said that. I might have misheard it. Okay, so come up with a number there that looks like it would be that volume. And that's volume of box number 1. What's the volume of box number 2? I'm sorry, what? Well, give it to me without a final number. Give it to me in this format that I've written it here.
Alright, so 8 times 8 times 30 would be volume 2.
It's always worth doing that, Nick, just because it reinforces in your mind how you get volume, rather than immediately coming up with a number.
Yeah.
Okay, now, what's 64 times 30? Now we need a number.
Alright, hold on, let me get my calculator. That's 1,920.
How much?
1920.
Okay. Which popcorn box do you want?
I'll take box 1.
Okay. All right. We're done with that page. What else you got?
I don't think I have anything else. I'll look.
Okay.
Yeah, that was all we had.
Huh? All right. That's it for tonight?
Yeah.
All right. No problem. Nick, I will talk to you next Wednesday.
Alright.
You got to be coming down close to finals, right?
Yes, indeed.
They'll be giving you review material, I presume?
I'm sure they will be.
Okay. We probably want to start working on that as soon as we can.
Yeah.
It can't be more than, when's your final? Your final's got to be in 2 or 3 weeks max. When's your last day of school?
I don't know the exact date. I do know it's in like at least like, I think it's 23 days.
Okay. So it's the last week of May. You're sometime then, huh?
Yeah, something around there.
Okay. Nick, I'll talk to you next week. Bye-bye.
Alright, good. Bye-bye.